Hello, this recording is for Pre-Algebra Chapter 4, Lesson 5. Basically, we're doing word problems for this lesson, and some of them will be solved a way that you guys are already familiar with, called the tennis problem. Basically, the tennis problem is if we have like 10 people and each person needs to play the other person once, how many games will be played? So we're going to do something similar to that for at least two of the problems, and so let's see if you can identify them. Right, the first problem is Mandy, Jim, Keisha, Darren, Lynn, Chris, and Jen are friends. They want to take pictures of themselves with two friends in each picture. How many pictures do they need to take? Well, basically, I'm going to make a list of all the people, and then I'm going to shorten their name. And since I have two J's, I'm going to turn Jen into an E instead of a J so that I can keep track of them. So now I'm going to write down how many people are going to take pictures, or which people are going to take pictures with Mandy. Well, Mandy needs to take a picture with each of the other people. So she needs to take a picture with Jim, Keisha, Darren, Lynn, Chris, and Jen. And remember, Jen is E in this case. So she's going to take 6 pictures. Now, let's figure out how many pictures Jim needs to take. Well, Jim's already taken a picture with Mandy, so we don't need to count Mandy again. But Jim needs to take a picture with Keisha, Darren, Lynn, Chris, and Jen. So that's 5 pictures, and now he really has taken 6, but we counted him towards Mandy, all right, because there is a little bit of overlap, so that's how we take care of it. Now, Keisha has already taken pictures with Mandy and Jim, so they don't count, so Keisha still needs to take pictures with Darren, Lynn, Chris, and Jen. Here you guys starting to see a pattern. Darren already taken pictures with Keisha, Jim, and Mandy, so therefore he only needs to take 3 more pictures. And so on, and so on, and so on. You guys see the pattern? I hope you do. If you don't, come see me, all right? Now we got to add up all the pictures together. Guess what? They took 21 photos. This is what we call a tennis problem. Get used to it, all right? Because this works just for tennis, like tennis problems as well. Like how many games were played if you have 10 players in a tennis match. You get the idea, right? All right, moving on. All right, next problem is you decide to number the 58 pages in your journal from 1 to 58. How many digits do you have to write? Well, let's think about it. Pages 1 through 9. The numbers 1 through 9 only have 1 digit per page. The number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, all the way up to 9. So 9 pages total. But once we get to 10 pages, things change because the number 10 has 2 digits, the number 1 and the number 0, whereas the page number 11 has 2 digits, 1 and 1. Page 12 has 2 digits, 1 and 2. All right, so that's what they mean by digits, okay? So if there's 2 digits per page and 10 pages total, that's going to come important again, and it's going to go all the way up to 58. So I set these up in increments of 10. 10 to 19 is 10 pages. 20 to 29 is 10 pages, 30 to 39 is 10 pages, 40 to 49 is 10 pages, and 50 to 58 is not 10 pages. It is 9 pages. Okay? So, now, how many digits do I actually have? Well, 1 digit for 9 pages is 9 total digits. So that would be the digits for pages 1 through 9. But I have 2 digits per page and 10 pages when it comes to 10 through 19. So there's 20 digits for 10 through 19. There's also 20 digits for 20 to 29, 30 to 39, 40 to 49, but there isn't 10 pages for 50 to 58. There's only 9 pages. So the total number of digits is 9, 20, 20, 20, and 18. So add them all up together and we get 107 digits that you have to write to number your journal. All right? Okay. So, second to last problem. How many triangles are there? Well, I'm sure you guys can figure out that there are 9 small triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 small triangles. And then there is 1 medium triangle. There's another medium triangle. And a third medium triangle. Plus, there's 1 large triangle. Okay? And then you add them all up and we get 13 triangles. Okay. Oh, I take it back. There's 2 problems left. There's this one and the one after it. Okay. So you have pepperoni, mushrooms, onions, and green peppers. How many different pizzas can you make by using 1, 2, 3, or 4 toppings? So if you're only using 1 topping, obviously you're going to have a pepperoni pizza, a mushroom pizza, an onion pizza, and a green pepper pizza. There's 4 different pizzas, right? Now, what about two toppings? Well, the two topping ones is like the tennis problem. Well, you can have a pizza and mushroom, a pizza and onion, and a pizza green pepper, and that's 3 pizzas. A mushroom and onion and a mushroom and green pepper, which is 2, and onion and green pepper, which is 1, and then we've already used green pepper enough. So we now have 6 pizzas, or 10 pizzas, because we have the 6 and the 4 from the 1 and 2 toppings. 3 topping pizza, pepperoni, mushroom, and onion, pepperoni, onion, and green pepper, pepperoni, mushroom, and green pepper, and mushroom, onion, and green pepper. So there's 4 pizzas that we can make that have 3 different topping combinations. Now we have 4 toppings. Well, there's only 4 toppings possible, so we can only have 1 type of pizza that has all 4 on it. So it's a total of 15 different types of pizzas. All right, last problem. And guess what? It's a tennis problem. So we have 8 people at a party. Everyone shakes hands once with everyone else. How many handshakes are there altogether? Well, since I have 8 people and I don't know their names, I'm just going to give them letters of the alphabet. Maybe you have Albert and Bernice and Clyde and Dylan and Ethan and Frank, George, and Hank. All of them got to shake hands, right? So Albert's going to shake hands with Bernice, Clyde, Dylan, Ethan, Frank, George, and Hank, and that's 7 handshakes. But Albert's now already shaken hands with Bernice, so Albert doesn't have to do that again, but Bernice still has to shake hands with Clyde, Dylan, Ethan, Frank, George, and Hank, right? So then there you go. Then you guys see the pattern from the tennis problem before, so it adds up, and you get 28 handshakes. All right, guys, make sure you can identify those tennis problems. All right, bye.